All right, we will continue our target 5 notes, and we left them off yesterday at 21, finishing it. We skipped 19 and 20. Also, we're going to replace 25 and 26. If you want to go ahead and pause the video and make note of that. But these are only 7 examples of finishing this up. But this is where I kind of get a little bit worried, not being able to answer your questions. So the Google Meet. We tried that out and it worked pretty well today, so I think we can use that. We just might need to schedule a specific time and day, or at least a couple times and days where I can start answering some homework questions, specifically this target probably. I think you probably got through targets 1, 2, and even 3 pretty well with the videos and the practice and the tutorials on Math Excel, but this one might give a little more trouble. So stick with it and know that I'll be there to help later. But here's a few more examples of Algebra 2 and irrational exponents. And again, it all revolves around these rules of exponents, where you add them, multiply exponents, subtract them, or everything in the parentheses gets the exponent. So keep those in mind. So without further ado, here we go. These 4 bullets guide us. You can't have a negative exponent, got one of those. Can't have fractional exponents in the denominator, got one of those. So there's a lot of reasons we got to do something to quote unquote simplify number 19. So my first step would be to deal with the negative exponent. And by dealing with the negative exponent, that means it moved from the bottom of the fraction to the top and joined the x to the 2/3. So it's multiplied by x to the 2/3, and now it's a positive exponent. Then the property kicks in that says you have multiple things in a parentheses, each item in the parentheses gets squared. Well, in this example, each item gets raised to the 12th. So that would look like this. X to the 2/3 gets raised to the 12th, and the y to the 3/4 gets raised to the 12th. Then your exponent raised to an exponent property kicks in, and you multiply those exponents. So when you multiply x to the 2/3 times 12 and y to the 3/4 times 12, you get nice answers. 2/3 times 12. Hopefully you just know how to multiply them or use your calculator, but it's 2 times 12, 24 divided by 3. 24 divided by 3 is 8. 3/4 times 12 is 3 times 12, 36 divided by 4, so 9. So final answer here would be x to the 8th, y to the 9th. In our next example, number 20, we have an x to the negative 1 in the bottom. Can't have that, so we're going to move it to the top. It's going to join those 4 x's, x to the 4th times x to the positive 1, to become x to the positive 5. That is the negative exponent property, and the multiply the same base, add your exponents property. The last property would be you can't have a power raised to a power. You can't have a complex fraction. Well, you can't have a power raised to a power. You have to simplify that by multiplying those 2 exponents. X to the 5 times 1/3 would be 5 times 1 over 3. So x to the 5/3. In general, I'll go ahead and say this now, in general, the general rule of thumb, if your problem starts with exponents, you finish it with exponents. So these last 2 down here, they're starting as radicals. We may temporarily use exponents to reduce them, but we'll finish the problem in radical form. That's just general rule of thumb. 22 here, 22. Everything in this parentheses gets raised to the half. So the exponent rule says the 16 gets raised to the half. The x to the 4th gets raised to the half. In the bottom, the 25 gets raised to the power of 1/2. And the y to the 12th gets raised to the power of 1/2. The number part of this, 16 to the half, is like square root of 16. 25 to the 1/2, like square root of 25. So the number part is 4 over 5. The variable x to the 4th raised to the half, a power raised to a power, you multiply those exponents again, so 4 times a half, x squared. In the denominator, it's y to the 12th raised to the half, and you multiply those exponents and get y to the 6th. So now we've reduced this as far as we can. No more x's to put together or y's. Everything's reduced as far as possible. Next example, 23. I went a little more detailed on 23 here and showed that the top of the fraction gets the exponent. The bottom of the fraction gets the exponent. Well, about the same detail, sorry, not more detail, about the same detail as the last one. So 125 gets the exponent 1/3, gets raised to 1/3. Well, that's cube root of 125. That's 5. X to the 6 gets raised to the 1/3, so multiply your exponents. X to the 2. 216 to the 1/3, cube root of 216, 6. And y to the 15th raised to the 3rd, multiply your exponents. So final answer, 5x squared, 6y to the 5th. Let's see, 24. We have two negative exponents. So first step I would do is to flip where x to the 2/3 in the bottom, y to the 1/3 in the top, and that would be positive exponents then. So the negative exponent rule says to flip them. Now the exponent 15 gets distributed to the top of the fraction and to the bottom of the fraction, where we once again will have a power raised to a power, power raised to a power, so multiply the exponents. Y to the 1/3 times 15. 1/3 times 15 is 5. 2/3 times 15 is 2 times 15, 30 divided by 3, so 10. You're going to get a y to the 5th and an x to the 10th. Final answer, y to the 5th over x to the 10th. All right, now these last two illustrate that property that's probably the weirdest of all of them, that you need to meet the criteria where the index of the remaining radical is the least number possible. So here's what that means. Typically, with a 6th root, you need perfect 6th powers. With a 4th root, you need perfect 4th powers. But the property that allows us to switch these from radical form to exponential form, this radical to exponential form, allows us to use exponential properties to reduce as we can. So that's going to happen in these two. The first step in these is to rewrite them in exponential form. So that would be something to the 1/6. A 6th root is like a 1/6 exponent. Everything in this radicand raised to the 1/6. Same thing over here with number 26. That would be everything in the radicand raised to the power of 1/4. So our first step is to rewrite them in exponential form like that, like we did at the beginning of the first day of target 5. Now the exponent rule kicks in that we can distribute our exponent to each item, and it would look like this in the first problem. We'll finish the second one over here in just a second. But your x squared gets raised to the 1/6, and your y to the 4th gets raised to the 1/6. And now the multiply your exponent property kicks in, and you get x to the 2/6, which is 1/3, and y to the 4/6, which is also 2/3. So we're going to end up getting fractions that reduce to 1/3 and 2/3. So technically that's reduced, but the general rule of thumb, again, is if it starts as a square root or a cube root or any radical, you finish your answer as a radical. Those are exponents. So we need to change this in the very last step back to radicals. So it'll be a cube root. They're both cube roots. In index 3, index 3. So they're both cube roots, and it'll be x to the 1, y to the 2 under it. So it'll look like cube root, x to the 1, y to the 2. Final answer for that one. When we use our exponent rules over here, something else reduces. 16 gets raised to the 1/4. X to the 2 gets raised to 1/4. So 16 to the 1/4, that is a perfect 4th power. If you look at your 4th power sheet, 2 to the 4th is 16. So that's like 4th root of 16, it's 2. X to the 2 raised to the 4th, you multiply your exponents, you get x to the 1/2. So again, started as a radical, need to finish this as a radical. Now which one of these has the exponent 1/2? The 2 or the x? Just the x. So when you write it in radical form, only the x has a radical. 2 is just a 2. So it would look like this. 2 square roots of x. Final answer. So homework will be a little bit more of a challenge. The video is about 10 minutes today. So I'll give you a few extra minutes to try the homework. We'll probably need to do a Google Meet and set it up to where I can work a few of the homework questions possibly. We'll also be reviewing this target in the next day or so, so we can set up a review session then to go over some homework problems. But I'll definitely try to make myself available for homework questions for target 5 at this point. So just look for that announcement in Google Classroom.